Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as always. I'm at a lower level today because I've got a VOX AC30 and I can't lift the damn thing up onto the bench. It's ridiculously heavy, insane. Anyway, the two most difficult faults in my view to fix on an amp are amps that are oscillating and amps that won't oscillate. So let me explain what I mean. An oscillating amp is one where you get a horrible or whatever as soon as you turn it on. The entire amp is oscillating. And the reason that's very hard to fix is because you can't break the circuit anyway. You can't say, oh, I'll take out V2 and see if that's the bit that's causing the oscillation, because anything you do will just stop the oscillation dead. So you have to resort to a number of arcane tips and tricks to stop the amp oscillating. I had one in recently actually, and I had to do this, and I reversed the phase of the primary of the output transformer, and that's a little trick you might want to keep up your sleeve, and that did cure the oscillation. Anyway, that's oscillating amps. This amp is not an oscillating amp, and that's the trouble, because the vibrato doesn't work. In other words, the vibrato oscillator on this amp is not functioning. Now again, that's not particularly easy to find. Interestingly enough, because what's stopping it oscillating? It could be a number of things. So again, we have to get kind of quite clever and see what we can find out with the oscillation stage. Obviously, I'm going to do some fairly obvious things like change the oscillator valve and then have a good, thorough visual inspection. Anyway, that's the problem with this amp, and apparently, what I don't like about it even more is it's never oscillated, or we can't remember the last time it oscillated. Well, it's not like it's not like it was working last week and now suddenly the vibrato doesn't work. So again, that's not nice. Now, you may or may not know there are dozens of different versions of the VOX AC30. You can't keep track of it. You'd have to make it your specialist mastermind subject, the history of the VOX AC30. So I don't know which one this is. Probably some Mexico version or something. But anyway, let's get the back off, have a look inside and see if we can fix the vibrato on this amp. Otherwise, apparently it's all okay. Okay, here we are inside the amp, and it's a PCB version, so it's a reasonably recent one, not an old AC30 or anything, one of the many clones of this, and it all looks reasonably tidy. There's the foot switch right here, look. And the wires on it look good, and they go up to here where it is marked foot switch, so we're on the right track there. I will just short that to that with a crop clip, just to make absolutely sure we're not being silly here. Other than that, you know, it all looks good. So the next thing for me to do will be to give it a visual inspection inside, just to make sure I can't see any burnt components or desoldered components or anything. I doubt we'll get that lucky. And then we need to try and find and locate the oscillator stage, which won't be particularly easy, but one way of doing that is to put a signal through it and then just pull the preamp valves one by one and find the one that doesn't kill the signal. Obviously all the others will be in the signal chain, and the one that doesn't kill the signal is almost certainly the vibrato oscillator, and at that point of course we can just change that valve and see if we get lucky with that. I don't really think we will, but we've got to eliminate the obvious first of all. I would be surprised if this wasn't the oscillator section here. I'll tell you why. These three capacitors immediately caught my eye. There's three 10 nanofarad capacitors, and in order to get the phase shift around the oscillator to make it oscillate, you put these three capacitors in series like this. There's no other reason to have three 10 nanofarad capacitors, so I think that's the oscillator there. And of course we know that the foot switch comes here, so it's not down there somewhere, so it's around about here. So my guess is that this is the oscillation, the oscillator here. I've tried changing that trim pot a bit just in case that had some dirt on it and there was open circuit or something, but that hasn't brought it to life. Yeah, and the fact that these vibrato and tremolo controls are here, again very close to this, look, implies to me that this is the oscillation section here. Of course, typically on these VOXs you can't do anything as crazy as change a valve. I mean, come on, don't be silly. The valves are not at all accessible on this amp without completely dismantling it. You know what absolutely crazy design is that? In order to change a valve on the amp you have to completely dismantle it. Ridiculous. So anyway, we're going to have to get the chassis out and up on the bench, I think, and then we can at least change the oscillator valve, which is here. These are the power valves here, the 3 EL84s. And we want to have a look at everything anyway to see what kind of state everything's in. There's nothing obvious there. No obviously duff components or anything. The joints on the valve base look okay. They're not fantastic, but I don't think there are any bad joints on there. So I think the next stage is to actually just get the chassis out and get it up on the bench. Right, here we are, top side of the amp. And well, the first thing I notice is the corrosion on these transformers here. Not quite sure what this is all about. Not too badly corroded otherwise, not great. And same on the output transformer here, very just generally corroded, although this isn't, this is shiny. Very strange. The valves here, they look original to me. A Mark 6BQ5, and that's a Phillips valve, that one there, so I don't know what the provenance of these valves are. I guess they might be original valve rectifier look. And then we've got usual selection of preamp valves here, a bit of a motley selection by the looks of it. This is the valve that I think is the oscillator valve. It's just a logical place for it, that. And you know, you might be saying, why don't I get the circuit diagram out? Well, because there are dozens of varieties of this amp, and to find this exact model and the exact circuit diagram will be actually quite difficult. So I'd like to fix this if I can without resorting to the schematic. I'm going to take that valve out and put a signal through, and if the signal gets all the way through, I think we can fairly well guarantee that's probably the oscillator valve. So let's do that. Okay, there we go. The guitar's plugged in. That works okay. That works okay. That works okay. So all the channels are working. Let's pull this valve and again, they're all working. So as suspected, this is almost certainly the oscillator valve, standard AC30, of course. I doubt it's faulty, but of course we have to replace it as the very first thing that we're going to do. So let's do that and see what happens. I've got a used one here, Electro Harmonics ECC83. We'll bung that in and see if anything springs to life. We should be so lucky, eh? Just let that warm up. Of course, we don't have the foot switch in, so I think we probably ought to plug that in. I can't remember. I think the foot switch has to be open circuit for this to work, and at the moment it's short circuit. So there we go, that valve will be warmed up now. So there's the signal, foot switch, nothing. Now I'm just pressing the foot switch. Nothing at all there. So we're going to have to get serious with this. I'm not totally convinced I can fix this. As I say, to get an oscillator to oscillate is as difficult as to get an oscillating amp to stop oscillating. All you can really do is check some voltages and check some resistor values and things. So anyway, let's turn the amp upside down and have a little poke around, see if we've got any voltage on the pin 1 and pin 6 of this valve, for example. Just do some basic checks. Right, let's have a little look around this valve. We have have 220 volts on pin 1, that's okay. 1, 2, 3, 4, 5, 6, and 220 volts on pin 6. So that's kind of what I'd expect. How is that foot switch open circuit or closed circuit at the moment? Okay, it's open circuit, that's good. And then when I press it, it should go short circuit. I'm over on the right hand side here, yeah. So that's okay, so the foot switch is actually working. I think it's got to be open circuit to work. Not totally sure about that actually. Maybe I'll need to find that out. But anyway, for the moment we can just switch between the two states. Okay, no, I'm on the wrong valve there. Because I've turned this upside down, we need to be over this side of the amp, not on the left. What was my left is now my right. So let's have a little look over here to see what we've got on this valve here. Right. Let me see. So pin 1. 194 volts, that's okay. 2, 3, 4, 5, 6. 94 volts. Bit lower than I might have thought. Bit on the low side that. 95 volts, but I don't really know what it should be. And here are our phase shifting caps here. Right, I think I'm gonna might have to try and find a schematic somehow for this. This section here, otherwise we are going to be struggling. I think I might just put the scope on here as well, just to make sure that this isn't oscillating. I'm pretty sure we'd hear it if it was, even very faintly we'd hear it going in the background. And there's nothing obviously wrong that I can see. I don't like the fact that this has never worked. Right, I'm just scoping around pins 1 and 6 on that oscillator valve. Pin 1's okay. When I go on to pin 6, 9876 there, we get this horrible hummy with very high frequencies all over it. Very nasty waveform there. See, I mean, it almost looks like it's oscillating, but it's only 500 millivolts that, and that's, you probably can't see, but underneath here there's very, very high frequency stuff going on. Don't know whether I can. There it is. There, you can just about see it. Look, exceptionally high frequency there. We're up to many kilohertz with several megahertz superimposed on here. So something very open circuity feeling about this. Pin 6 is definitely not right. So we need to have a little look around what's going on around there. But I think we might need the schematic for this. Okay, I've been over the joints on the valve base there. I don't know if something has changed or whether I just didn't hear it before, but see if you can hear this. I think it kind of wants to oscillate, so basically can't hear anything there. Now when I press this here, foot switch, you might hear it start to just oscillate once and then stop. Hear that? Woo woo. So from there to, you hear it go whoa 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 just once, but it's not oscillating properly. So I don't know whether that's progress or not, to be honest with you. Okay, I managed to find a schematic for this part of the amp, which is probably correct. I've checked some of the values and they seem to be right. So this is the oscillator section, and this is the 1990s Korg version of the amplifier. I've checked back on the 1980s diagram, and it's the same as this, because of course no one's going to completely redesign this. Most people aren't capable of it, that's the first thing, myself included by the way, and it's just much easier to nick a circuit from 10, 20, 30, 40 years ago, and if it works, well, why not? So this is the oscillator section here. I won't go into huge detail. Here are the phase shifting capacitors here, which take this signal here and shift it by probably 180 by the time it gets back to here, so that we've got positive feedback here, and you need positive feedback to cause an oscillation. So this basically oscillates here at 10 Hertz or something. So it's a fairly simple oscillator, not a lot to go wrong with it, and I think we can accept that short circuiting the foot switch, in other words taking this point to ground, turns the oscillator on, because otherwise these resistors here are just floating up with no connection. So I'm pretty sure that shorting this turns the oscillator on. I've been around and checked all the values of these resistors here, and they're all okay, so there's no problem there. I guess one thing we should do is to check this capacitor here. I have checked that it's 3K9 across there, which it is, so this isn't short circuit, this capacitor. I guess it could be open circuit, clutching at straws a bit here. Now if this capacitor wasn't working, the gain of this stage would drop dramatically, and it probably wouldn't be enough gain to make it oscillate. So that's obviously a likely contender. We'll swap that. I'm not hopeful. We'll swap that and see how we get on. We're going to have to take a view on this. Obviously time is money, and we can go on and on, trying to find out why this oscillator, which is apparently according to the customer has never oscillated, isn't oscillating. But anyway, I think we'll push on a little bit longer and see if we can make any progress. Okay, I changed that electrolytic, and as expected it's made no difference. Possibly a little bit of progress, I'm not totally sure, but just have a look at this. So this is the speed control part of the circuit. I've been going around with my meter and just measuring that this is connected to here, this is connected to here, that's connected to there, and so. We haven't got any kind of missing connections. Now this speed control shorts one of these resistors down to ground at a time. Let's just have a look here. Now interestingly, this shows a 3-speed control, and the speed control on this one is 1, 2, 3, 4, 5, 6, goes all the way around. I'm not quite sure what's happening there. So if I put my meter on this point here and to ground, and on a fairly high resistance, in other words 1 meg plus measurable, I would expect that at some point in my rotation of this speed control here, seems to have 8 positions, that one of those positions, say this one, would short that 560k to ground, and I'd measure a resistance change, or it would short this 1 meg to ground, and I'd measure that resistance change, or I'd short this to ground, I get that 330k there. But no matter where I turn the speed control with my resistance probe here and on ground and on about 2 meg, I don't get any resistance measure at all on any position of the speed control. So I think we have a problem here. Obviously if none of these are shorted to ground, I don't think this will, well, I know it won't work, this won't oscillate. So it looks like it might be something to do with this speed control here. So here are the 3 resistors here, and I can see the traces going off to the speed control. I am measuring on a 2 megohm range, so that will easily cope with our 330k, 560k and 1 meg. I'm putting my probe, short the probe, look, I'm getting 0 ohms there, so that's all okay. Now I'm going to go on the junction of these 3 here. These 3 are all joined together. That's this point here on the schematic, look. And I'm going to go to ground with the other side of the probe. Make sure well on, and no matter where I rotate this speed control here, I'm not getting anything. And in fact, if I go on to, say, here, which is that 330k there, I'd expect to get a dead short at some point, wouldn't you? So 330k, and no matter where I turn this speed control, I'm not getting anything there. And it's just for sake of argument, we'll go on the 560k, again, no matter where I turn this, no short circuit to ground, and here 1 meg, no shortage to ground. So that seems to be, I think, the issue. Now what's actually causing that I don't know. So let me investigate a little bit further to find out what this it's a bit weird the way they've done this. They've got a little subboard behind here, and I don't know how that subboard is connected to the main board. Not very obvious at all that actually how that's connected. Nope, I'm going to have a look at that. Okay, the plot thickens here. I've got one end of the meter on ground, and I'm now going to probe the wiper of the speed switch, and as you can see that is connected to ground, exactly what you might expect. And now I can go around the pins of the switch, so that one's connected to ground. When I turn the switch, that goes off, but the next one is connected to ground, exactly what we'd expect. When I turn the switch, that goes off, and the next one's connected to ground, that goes off, next one, 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 all the way around the switch. So the switch is working perfectly and it's connecting its output pins to ground. However, when I look at some of these tracks here that seem to be coming from this switch, it's very hard to see because they're all underneath this board here. And these are the tracks that go up to our resistors here. Again, I can go on these tracks here and absolutely nada. So it looks like these output pins here are not connected to the tracks here. Now, diagnosing that's going to be a little bit difficult. I don't really want to take this whole board out if I can avoid it, but I might have to. Can't really see how these pins here get down to the tracks. There are no tracks on this side of the board here going down to, from these output pins, there are no tracks going down, so they must all be on the other side of this board, I think. Let's power the amp up again and short circuit these resistors in turn down to ground and see if the tremolo comes to life. That'll be a bit of progress, wouldn't it? It'd be nice to actually hear a tremolo sound. So let's do that. Plug in, and we'll clip a crock lead to ground, and it doesn't really matter which one we're short. Okay. Well. Listen to that. Houston, we have a tremolo. And as we go down to this other resistor, it should be a bit slower probably. Right, so I think we have on the route to solving this. I'll just turn that off. So for some reason, the outputs of this switch here are not connected to the tracks that go to this board. Okay, here's the board here, and it's not easy to see how they've put that in, actually. And very loath to take this entire board out. It was quite a big strip down procedure. I would add about £75 onto the customer's bill. So I'm going to take an executive decision here, and I'm going to take 3 wires from these pins here, you know, pins 1, 2 and 3, positions 1, 2, 3 on the switch. I'm going to take them over to these resistors here and just solder them on there. And that will restore the tremolo function. I wonder if the vibrato works. In other words, I wonder if this switch is doing anything. I think I might try that first. The customer says he's not sort of overly fussed about it. If I can't get it working, no worries. He'll use it as it is. So I think if I got the tremolo working, there was no vibrato, he probably would be happy with that. And of course, all the question of money, we can go on and on and on. I'm not going to charge the customer what I've spent so far, even, because I've probably been 3 hours on it already, and that's, you know, £100 just before we've even started. So I'll probably write that off and just charge him for this modification here, and that will restore the tremolo function. So I'm going to power the amp up again and see if the vibrato works, and then I'm going to do that mod and see if that gets us out of trouble. Okay, the good news is the vibrato works. So this is the tremolo, and then sorry, that's the tremolo there. A vibrato, I beg your pardon, always get the two mixed up. Vibrato, and then when we go to tremolo, that's working. So this switch is working well. It's just this one that isn't, for reasons unknown. Part of me would like to find out why it's not working, but part of me can't be bothered, so sure you know what I mean. Right, so that mod now I think will work. We'll take the wires from there across to there, and that will get us out of trouble. Right, there's the mod done there, 3 wires, and position 1, 2 and 3, the fastest. And the vibrato tremolo works okay. So there we go, that's that done. My view is that this probably never worked out of the factory. That would be my guess. There's something obviously wrong with the connections between this board here and the board underneath, and to find that we need to take out the entire board, all the controls, all the subboards, all the valves have to come out. It's all doable, but it's just time really. So the customer, I know, will be very happy with this little workaround here. Okay, fantastic. Well, there we go. Well, there you go. Hope you enjoyed that one. Fault finding at its best, really. I don't mean that I'm the best, I just mean the sequence of events. Oscillator is very hard to fix. It's either oscillating or it's not, and you can't kind of fault find stage by stage. But I did exactly what was needed there. Just check all the resistors, check all the joints, check the valve, check the obvious electrolytic capacitor, and it was by that meticulous testing, is this point connected to this point, is this point connected to that point, that showed up the fact that those 3 resistors were never grounded by that speed switch. I think that's been like that since the factory. So he said it had never worked, and it's not that old, so I don't know what's gone on there. I would have been quite interested to take the board out and see exactly why that wasn't working, that switch, but it would have been 2-3 hours work, which is just not worth doing. Customer's very happy. I've spoken to him already, and delighted to have the tremolo working. He doesn't want to spend a fortune on the amp, so that was a good decision all round. Well, I hope you enjoyed it. I certainly enjoyed that one, and I like a bit of a mystery. I'll catch you on the next video. Thanks ever so much for watching, as always.